Welcome to the BP Learning tutorial series on chemistry. In this course, we're going to be using the book Exploring Creation with Chemistry by Apologia Press. Now, if you're using another chemistry book, you'll probably still find this course helpful, but the course sequence is focused on what you'll find in the Apologia book. This is part one of the series, and this just introduces the book, the method, why we study chemistry, and we also talk about what I call the golden rule of chemistry, which is not listed in the book, but I think will help out your study of chemistry quite a bit. So let's start with why study chemistry. Well, chemistry is the building block of everything that you see and touch. All the materials, if you think about like your whiteboards are made from chemistry. There's some sort of chemical substance that somebody developed to put on those whiteboards. I mean, honestly, everything is chemistry because everything is made up of atoms and molecules, and there's nothing that isn't made up of atoms and molecules. But the development of new materials is where people actually put chemistry to use. All the plastics, all of the glues, all these things that we use, that are used in all the things that we use every day, all of these things were developed from chemistry. Not only that, it's not enough just to have invented a new material or a new substance that does something cool. You also have to figure out how to produce it. And that production process also involves quite a bit of chemistry. That's a field called chemical engineering, and it's where you learn how to take an idea for developing a small amount of substance and you say, well, how can we automate this so that we can make barrels and barrels of this stuff every day? So if you imagine, coming up with the idea of a dry erase marker is nice, but it doesn't do any good if everybody has to hand make their dry erase marker. Well, instead, what we do is we build factories that produce millions and millions of these things. So you need chemistry not only to figure out how to make the marker in the first place, how to make something that will write and then wipe off, but you also need chemistry to figure out how do we mass produce these things on a large scale in a sustainable way. How do we not just produce one but millions of them? So chemistry as a field focuses on the development of these materials that make our life so easy and the materials that are used for the things that make our life so easy. But they're also foundation for other fields. As I said, everything's made of atoms and molecules and their interactions. Biology especially uses chemistry quite a bit, especially when you get to the lower levels like microbiology and biochemistry. Those fields make quite a bit of use of chemistry because they're dealing with the chemicals that are made in and secreted by cells. The information that's stored in a cell is stored on just a bare molecule called DNA. And all these molecules interact with each other, and they're just chemical reactions. But even if you're not going into a field that has anything to do with chemistry, there's actually really important reasons to study chemistry. I view education as being not only teaching us about individual fields, but also teaching us important ways of thinking that can be helpful all over the place. And so there are ways of thinking that we learn in chemistry that are helpful. First of all, it's practice applying philosophical reasoning. We'll talk about that later when we talk about the golden rule of chemistry. But most people aren't aware that most of science actually comes out of philosophy. The rules of reasoning for science are actually set in philosophy. And so as we apply these rules of reasoning, we're actually applying philosophical principles, and it's good practice. Even if you never use chemistry again, the practice of applying these principles to problems will help you in any area. Second thing is that it's good practice applying mathematics and mathematical formulas. Math books only have very basic word problems that they use to kind of help you get practice using math, but math is everywhere, and you're going to wind up with formulas for everything, whether you do business, you do science, whatever you do, there's probably going to be a formula for something. And so chemistry is most people's first time to really encounter applied mathematical formulas. And so sometimes the formulas in chemistry, and specifically in this book, are not difficult formulas, but sometimes they are difficult for people just because this is their first time to really take a formula and apply it to a real world situation. As I said, none of the formulas are hard in and of themselves. It's just that since most people coming to this have not had experience with this before, it may take them a little while to catch on to how formulas get used in the real world. And the final thing is it's practice reasoning about unseen things. There's a lot in our world that isn't seen. That's both from science and spiritual aspects. There are scientific things that we can't see. We can't see atoms. We can't see molecules. We can't see forces. We can't see fields. But likewise, there's spiritual things we can't see. We can't see our souls. We can't see morality. Any number of things that we can't see. And so, in chemistry, we can't see the things that we're talking about either. We can't even see heat. We might see some of the effects of heat. But what chemistry helps us do is it helps us combine understanding what we don't see based on the effects that we do see. And I think this is a good thing to think about, whether you're going to go into a hard science like physics and chemistry, or if you're going to go into a subject like theology. All of these things depend on us being able to relate the things that we see to the things that we don't see but are equally real. And chemistry is a good gateway to that. So, on a big picture view, what we're going to be studying in chemistry is we're going to be studying, first of all, what is everything made of? What are the components of everything? What are these atoms and molecules we're talking about? How do they fit together? The second thing we're talking about is how do things interact together? So, when you put together two chemicals, what happens? How can we understand what happens there? When you heat something up, what's happening? What is heat? Where does it go? What's the relationship between heat and temperature, and what does that have to do with chemical reactions? And then once we understand what everything's made of and how does it interact together, we say, well, how can we use our understanding to predict outcomes? If you have material X and material Y, what are things that are likely to be produced? Will this reaction go forward or backward? How much stuff can we make? Can we take our understanding of how the world works and use it productively? Use it to predict things. Use it to understand if we want to get X, how do we get there? And then finally, we talk a lot. We won't talk about this quite as much in this tutorial series, but the book talks a lot about how did we get this knowledge in the first place? What were the steps that people went through to gain this understanding? And so studying chemistry helps us with all of these areas. So about the book is a good introduction to chemistry, but the problem is that it gets really wordy. It uses a lot of words to talk about subjects, and that's actually helpful when you're reading it, because I'll tell you, I've read a lot of books that didn't use a lot of words, and what happens is that they'll introduce a concept and you'll be totally floored by the concept, but they won't bother explaining it. And so in some books, you're like, I wish they were a little bit more wordy. The problem with wordiness is that at the end, you're kind of at a loss for which parts of that you really need to hang on to. And really, in this book, in chemistry, there's not actually that many, at least in basic chemistry, there's not really that many. There's not that many things that you actually have to know. Most chapters can be condensed down to just a page or two of material that you have to know. Now, you have to have read the book in order to understand that page or two of material. But really, there's only a small amount that you have to actually remember from each chapter to work problems and to understand going forward. So this tutorial series, we're going to assume that you've read the book and are looking to boil it down to the important information. And that's what we're going to give you, is we're going to say, okay, well, this book had all these words about all these things. What are the things that you need to know? And so by using the book and this tutorial series in combination, I think you'll find that you'll have a really good grasp of the concepts, the formulas, and how to apply them. Now the one topic, this is an introductory video, so we're not going to cover a lot of actual chemistry, but the one thing that I wanted to focus on, the one new idea in this video, is what I call the golden rule of chemistry. And this isn't really in the book, but I think understanding this helps you, will help you understand what's going on in the book a lot. So in philosophy, there's this concept called ex nihilo nihil fit. And what that means is out of nothing, nothing comes. So basically, anything that happens, there had to be precursors to that. And there have to be things that happen after that. And if you have an anything, whatever it is, that anything didn't come from nowhere. Nothing produces nothing. And so therefore, if you have something, it came from somewhere. If you have a lot of things, then all those things came from somewhere. And if later you have fewer things, well, they had to go somewhere. So Paul Melson calls this the no magic principle. And basically it says that, whatever you have, there had to be a place that it came from. And whatever left, there had to be a place that it went to. And so once you understand this fundamental rule, understanding how to apply a lot of these equations and where these equations come from and why how they were built becomes a lot easier. You just recognize that if you have heat that came in, well, it had to come in from somewhere. And so if you can isolate the parts of the system that are bringing you heat, then you can calculate how much was brought in. You can, if you know how much started and how much is left at the end, then you can calculate how much went out. And so just all throughout chemistry, we're going to be just saying, okay, well, if we know that nothing comes from nothing, then that means that everything that we have had to come from somewhere. And everything that we used to have had to go somewhere. So anyway, that's what I call the golden rule of chemistry. And if you burn that into your mind, it actually makes a lot of chemistry and even physics and other sciences a lot easier. So anyway, I hope this series is going to be helpful for you. If you like and subscribe, that'll help get you updates as we get new videos out. And I hope you enjoy this series.